Hello, and welcome to a special edition of Ethanol Producer Magazine podcast. I'm your host, Katie Schroeder, Contributions Editor with EPM. Today we are hearing a panel preview for this year's upcoming Fuel Ethanol Workshop. This year, Track 1 will explore biological processes within production and operation. Michael Humphrey, Field Quality Manager with Lallemand Biofuels and Distilled Spirits, will be presenting in a panel titled Putting Antimicrobial Strategies into Action, happening at 3 p.m. on Monday, June 9th. Michael's presentation is titled An Investigation into Controlling Bacterial Persistence with Antimicrobial Peptides in Corn Mash Fermentations. Welcome to the show, Michael. I'm so excited to learn more about your topic.
Yeah, thank you very much. I appreciate the invite.
Absolutely. So could you tell us a little bit about yourself and what about this topic grabbed your attention?
Sure, yeah. I went to school at a smaller university for my undergraduate degree. It's called the University of North Georgia. It's nestled in the Appalachian Mountains, and essentially they don't have a biology degree, which was what I was interested in. So I took general biology courses and did a lot of undergraduate research in the area of microbiology because I wanted to learn as much as I could, and I got familiar with these cells called persisters. And so that's kind of what started my long fascination with the topic. And then moving into the position that I'm in now, working in industrial fermentation, we quite often see infections a lot in these industrial firms. And so I started pondering about how much persister formation could be contributing to some of these antimicrobial issues that we're seeing.
Great. Thank you for that introduction and background, Michael. So from your abstract, I saw that you mentioned persister and resistor microbes. So what is the difference between the two of them?
Yeah, sure. So we quite often hear the term resistance or antimicrobial resistance in both the medical world and industrial fermentation, right? So the difference is when we have a resistor microbe, it has a genetic change that has taken place in its genome. Quite often they're just single point mutations. And then once that change has occurred, that organism is now resistant to X antimicrobial treatment that you're applying to the system. For a persister, there's not really a genetic change in its actual genome, the microbe's genome that is occurring. It is a phenotypic physical change. So if you can imagine it's raining outside and you don a raincoat, right? So you're putting your raincoat on temporarily to shield yourself from the rain, but later on as the rain ceases to exist, you can shed that raincoat. And so that's kind of the difference. It's a physiological change that occurs versus a change in the actual genome of the organism. And essentially, because of this, the word transient is often used. Sometimes we can say that they're transiently resistant due to this phenotypic change. And so they can be transiently insensitive to antimicrobials. So that's the main difference. One is a genetic change in the resistance microbes, and then one is a phenotypic change, and we call those persister microbes. That's the main difference.
Fascinating. Thank you so much for digging into that. I would love to understand kind of what causes these persister microbes in an ethanol plant's process.
Yeah, so we know from medical studies that a lot of different things contribute to persister cell formation, and they can range from pH stress, oxidative stress, slow growth phases. So if we have conditions that are not conducive to exponential growth phase for microbes, they can enter persistence due to just growing slowly. We know that chemical pretreatment, which is kind of the focus here of the presentation that I'm going to be displaying, is that when we chemically pretreat microbes, it causes sometimes this phenotypic change and can make them more susceptible or less susceptible to being essentially killed with the antimicrobial. Other things such as reduced protein synthesis can cause resistance. So essentially these cells are entering a more dormant state. They're less active. So they're down-regulating processes of DNA replication, such as transcription and translation. And so there's many different contributing factors that have been explored regarding why cells go into persister states. But for the purposes of this podcast and my presentation, we're exploring basically pre-treatment with antimicrobial chemotherapy. So essentially looking at treating industrial corn mash fermenter with, say, a penicillin, and then what we call in a parallel treatment, adding penicillin again. Or in a serial treatment, we would add penicillin and then, let's say, erythromycin. And so that's kind of the investigation that we're looking at. How are the antibiotics influencing the entrance into this more dormant persister cell state?
Awesome. So, Michael, your abstract mentions a study using niacin. Could you talk about what that is?
Sure. So niacin is an antimicrobial peptide. So it's a little different from a traditional antibiotic. Antimicrobial peptides are naturally occurring. They're about 10 to 50 amino acids in length that are found in multiple organisms, whereas your traditional antibiotics are typically smaller molecules, and then they're often derived from microorganisms as well. If you think of penicillin, we derive that and produce that from bacteria and fungi. And so essentially they're proteins that act as antimicrobial agents. And so they primarily disrupt bacterial membranes by forming pores or causing the cell to leak or interfere with the cell wall linking in gram-positive organisms. The cell wall layer is called peptidoglycan. It kind of interferes with the linking of the cell wall as the organism is building it, similarly to penicillin. And so traditional antibiotics typically target specific things. So fluoroquinolines target gyrase. That's the protein that unwinds DNA during transcription, right? Penicillins, target the peptidoglycan cross-linking as well. Macrolides and streptomycins target the ribosomes and inhibit translation, DNA translation. So these antimicrobial peptides are more broad in their activity. And so the investigation here is to see how can we use them to reduce what potentially may be higher persister loads in industrial corn mash fermentations. Niacin's been studied for over 100 years. It belongs to a class of antimicrobial peptides called lantibiotics. And they are bacteriocins, which are just antimicrobial peptides. So niacin's about 34 amino acids long, and it has some unique characteristics in its structure that make it easily identifiable. So essentially, we're investigating the use of niacin with antimicrobials to see if we can further reduce the total bacterial population within industrial corn mash fermentations, and examining how far we can reduce these loads to have our yeast be able to have nice, productive, efficient fermentations.
Awesome. I'm excited to hear even more about this at the FEW, Michael. So thank you for giving us kind of a sneak peek. I'm looking forward to seeing you there, and I'm curious what you are excited about coming into this year's FEW in Omaha.
Sure, yeah. I'm excited for all the exhibits. I love going around and examining all of the new technology. It's similar to a Society for Industrial Microbiology conference where you get to go around and see all the new cool toys that we can use in the industrial fermentation world regarding ethanol. But I'm also excited to present on this topic. It is one that I've referenced one time previously, but got chosen to produce some other material and present at FEW. So yeah, I'm excited about this topic in general because we really don't hear about persister formation and really the implications of persister formation in industrial fermenters, because it's been studied more in the medical field. But that's not to say that we have the same implications of these types of things happening in industrial fermenters.
Right. Yeah. Yeah. Well, that's exciting. Thank you so much for your time today, Michael. If our listeners want to catch Michael's presentation, just a reminder, that is the Putting Antimicrobial Strategies into Action panel at 3 p.m. on Monday, June 9th. You can go to few.bbiconferences.com to see the full agenda, register, and learn more. Hope to see you there. Thank you so much for your time, Michael.
Thank you very much. I appreciate it.